Wait, spiel.
You're gonna have to wait till I go over there.
Ah.
Are you still doing it or no?
Yeah.
So you have to catch.
I stopped right here.
Where'd you stop?
Choroid plexus. Yeah.
So you have to catch.
I just didn't catch
I'll
you
do
on
choroid
that.
plexus again. Ready?
Ready.
Pick it right back up. All right. These ventricles have choroid plexuses in them. The choroid plexuses are a combination of blood vessels and ependymal cells. Like for example, this is the choroid plexus of my third ventricle. I know it's my third ventricle because I'm around my interthalamic adhesion. My third ventricle has my interthalamic adhesion running right through it, right where the stick is.
Yep.
So that's the choroid plexus of my third ventricle right there. If I could stick my stick through that septum pellucidum, I would be in my lateral ventricle and I could see the choroid plexus. Well, I have this, which shows me the choroid plexus of my third ventricle. Here's the septum pellucidum. If I turn it around, here's my lateral ventricle, and it looks like the jaguar you see here. So where's my choroid plexus of my lateral ventricle? All right here. This is where cerebral spinal fluid is made. And then if I look at my fourth ventricle, from my third ventricle right here, I run through the cerebral aqueduct right here, and I get to my fourth ventricle right here. There's the choroid plexus of my fourth ventricle right there. Now, lastly, I have some blood flow to the brain. And there's two of these clear skull models. I do ask you one thing, that you keep the brain to the clear skull models with the clear, you keep the correct brain with the correct clear skull. These are really cool brains that come all apart, as you can see. Look at all the parts. And they're very cool. All right. Keep the right brain with the correct skull. If I look in here, I have blood flow. Now what happens is I have a very important structure that makes a circle right here. And that's called a circle of Willis. So in theory, I could clog up this posterior cerebral artery, this posterior communicating artery right here. And I could still get blood to this part of the brain because it would come up this side, it would go across, it would come down, and it would go over. This circle of Willis is really cool because you could clog up a pretty major artery and still get blood to that part of the brain. 70% of our strokes are because of this artery right here. It's called the middle cerebral artery, and I'll come back to it. Let's name these blood vessels. The vertebral arteries are these arteries right here running through my transverse foramen of vertebrae. Remember how my cervical vertebrae, when they line up, remember how my cervical vertebrae have foramen in their transverse processes from Bio 203? If you don't remember that, cervical vertebrae have holes in their transverse processes. They're called transverse foramen. All of them together line up as transverse foramina, and my vertebral artery right there runs up through and enters up through here. Now look at it, it's entering through the foramen magnum. There's my vertebral artery on my left side and my vertebral artery on my right side. My vertebral arteries enter through my foramen magnum and they fuse right there. That's where my two vertebral arteries fuse. That's called the basilar or basilar artery. I usually say basilar. That's called the basilar artery. It looks like a centipede almost because it's a pretty thick artery with all these little legs coming off of it. Then I have these posterior cerebral arteries right here. Here and here. Right here and here are my posterior cerebral arteries. Well, what connects my posterior cerebral arteries to the rest of this circle of Willis? This posterior communicating artery right here. So you can see from the basilar artery, I have a posterior communicating artery that connects the basilar to the middle and the posterior cerebral to the middle. Here's my posterior communicating artery right here. Here's my posterior communicating artery right here. Right and left posterior communicating arteries. Now, my internal carotid artery, here's my common carotid artery, all right? Here's my external carotid artery, and here's my internal carotid artery. If you trace this internal carotid artery up and then see where it goes in, you will see that it goes in right here. This is my internal carotid artery entering my brain. Here's the other internal carotid artery entering my brain. Well, the basilar artery connects, the posterior communicating artery connects my basilar artery to my internal carotid. And it also connects my posterior communicating, also connects my posterior cerebral to my carotid, my internal carotid. So this is internal carotid, that's internal carotid. Then my internal carotids bifurcate, and right here you have a middle cerebral artery right here, and off of this internal carotid you have a middle cerebral artery. 70% of strokes are these middle cerebral arteries right here. Some branch of them, actually. Usually it's a smaller branch of the middle cerebral that gets clogged up, and that's where your stroke occurs. Then connecting my two internal carotids to each other is this anterior communicating artery. So really what makes the circle is my two posterior communicating arteries and my two anterior communicating arteries. That's really what makes the circle of Willis. But these communicating arteries attach a lot of things. Coming off my two anterior communicating arteries, my left and my right anterior communicating arteries, are these two anterior cerebral arteries running forward. Anterior cerebral, anterior cerebral. Anterior communicating, anterior communicating. The two anterior communicatings fuse in the center. My two posterior communicatings fuse at the basilar. I have my circle of Willis. I have my posterior cerebral, middle cerebral, anterior cerebral. All right, then I have these sinuses. Right here is a major superior sagittal sinus. Right here. Venous blood. These sinuses contain venous blood. And then I have another major sinus right here. Right here, and you can see it right in here even better. Right in there. That's called my transverse sinus. Now, what was this fissure called right here? Transverse fissure. Look what the transverse sinus does. It separates my cerebellum. I put the cerebellum back in there. Look how the transverse sinus is between the cerebellum and the rest of the brain.
Is that entire structure transverse, like here and then coming?
Oh, right here is where the superior sagittal comes down and meets the transverse. So it probably has a name, I don't know.
But down in here too?
Yes, that's transverse sinus right there.
Okay.
These sinuses join up with the internal jugular vein. Yeah, the jugular vein, that's just not on the model. These sinuses become the internal jugular vein. They join together and make the internal jugular vein. That's what these sinuses do. Any questions? I'm about to do this one more time. But now you guys can kick back and